Welcome to Student to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Today we're going over topic 1.12, confirming continuity over an interval. Remember the things to look out for. We gotta look out for zeros in the denominator, negative numbers inside even roots, and negative numbers inside of logarithms, because all of these will give us discontinuity. Our first problem is multiple choice, and we have to find a value k such that f of x is continuous at x equals 4. When we have a piecewise function, we gotta find the two pieces of the function that meet up at 4, and then we have to set them equal to each other. So we set each part equal to each other at x equals 4, and then we plug in x equals 4. And then from there, we simplify down so that we just have numbers and then variables. Once you're just left with that k variable, no other x's or anything else, we then put k on one side and all the numbers on the other side. And then we get k all by itself, and then we have our answer. Our next problem is in FRQ. The number of fish in a pond at time t years is modeled by the function n defined as this piecewise function, where f is a continuous function such that f of 0 equals 80. For the first part, we need to find n of t as t goes to infinity, and then explain the meaning of that. So first we're going to write down the limit of the function n of t, and then we're going to have to find that piece of that function that satisfies t being infinity, and that's going to be the part where t is greater than equal to 8. This part right here, and then we're going to put that over there. From here on, we take the two dominant portions of the ratio. That's going to be the 80t and the 0.05t, because as we go to infinity, these singular numbers that aren't changing with t are going to become negligible. This gives us an indeterminate form, and then we can use L'Hopital's rule in order to find our answer. We take the derivative of the top and the bottom, and then we're left with 80 over 0.05. That simplifies down to 1600. And here is our scoring guideline. And for this problem, like we were saying, we have to use that dominance on that 200 plus 80t over 2 plus 0.05t. So the next part is the function n continuous at t equals 8. Justify your answer. So like we did in that multiple choice problem, we're going to have to get the parts of the function that connect at 8, and then we're going to have to set them equal to each other. So we got the function as we're approaching 8 from the left equals the function as we're approaching 8 from the right. And that, of course, is going to be parts of the piecewise function over here. We got 25t plus 150 equals 200, yada yada yada. So for each of these parts, we're going to have to plug in 8 in for t, and then we'll have to see if we have a true or false statement. Left side we get 350, on the right side we get 840 over 2.4. And then if we simplify that down, we got 350 equals 350, which is a true statement. So therefore, the piecewise function would be continuous at 8. And for our scoring guideline, we have to use a 3-step process for providing continuity. For the limit, you must show that the limit from the right is equal to the limit of the left. And that is exactly what we did. For part C, the function n is continuous at t equals 6. Is there a time t, where t is in the interval from 0 to 6, at which n of t is equal to 250? Justify your answer. So we're going to have to find the value of the function n at the endpoints of that interval, 0 and 6, and then see if 250 is in between those numbers. So first we're going to find end of 6. We're going to have to find the part of the piecewise function that is involved with t being equal to 6, and then we plug in 6 into that t value. So for t equals 6, we're going to be using the part 25t plus 150. We plug in a 6, and then we get 300. And then for n of 0, in the description of the problem, it told us that f is a continuous function such that f of 0 equals 8. And f of t is the part of the n of t piecewise function when t equals 0. So when t equals 0, n of 0 equals f of 0, which equals 80. And then because 250 is in between n of 0, being 80, and n of 6, being 300, and we know that the function is continuous, then the intermediate value theorem guarantees at least one value c such that n of c equals 250. And for our scoring guideline, it tells us that we have to use the intermediate value theorem to find f of 6. You must use 25t plus 150, which is what we did. This has been 1.12 confirming continuity over an interval. Thank you for watching.